Hello everybody, this is Dr. Thunder. Today I would like to show you how to solve a US high school physics competition question. This is question number 5 of 2025 F equals MA exam. We have 3 identical cylinders in this question. 2 of them are placed side by side on a horizontal surface. The third one is placed on top of the first 2 so that their centers form equilateral triangles. And we consider the friction coefficient mu1, that's between 1 and 2 and between 1 and 3. And then mu2 is between cylinder 2 and the ground, and mu2 is also the friction coefficient between cylinder 3 and the ground. Now we want to find out which of the following pairs of mu1 and mu2 will make the system remain in equilibrium. So this is a relatively easy question. Let's look at cylinder 3 first. Cylinder 2 will be similar to cylinder 3, so we only look at 3. So let's look at the forces that act on cylinder 3. So we have N2 that is from the ground, and then F2 is the friction force. It's not difficult to figure out that F2 should point in left. And then N1 is the force from cylinder 1, and then F1 is the friction between them. And then it's also easy to figure out the direction of F1 should be along this direction. Remember, all these forces are forces that act on cylinder 3, not on cylinder 1. We're looking at cylinder 3 only. So that's first we look at the torque. The torque should be balanced. So we have relative to the center of cylinder 3, the torque for F1 will be RF1. For F2 should be R. F2. Remember, R is the radius of this cylinder. So we get a first equation, F1 equals to F2. F1 should be less than mu1 N1, and same F2 should be less than mu2 N2. We know that friction is not really a constant force. It may change. For example, the static friction is usually larger than the kinetic friction force. Now look at the force balance for cylinder 3 along the horizontal direction. So F1 cosine 30 degree. Remember, the center of the 3 cylinders form an equilateral triangle. So it's not difficult to figure out where the 30 degree comes from. So F cosine 30 degree plus F2, that should be equal to N1 sine 30 degree along that direction. So simplify to be the equation 2. And then along the vertical direction, F1 sine 30 degree plus N1 cosine 30 degree is, and then plus, remember cylinder 3 has a gravity mg, so all 3 forces are pointing downward, and then N2 is pointing upward, so they achieve the balance. So we can simplify to equation 3. Here it's not difficult to figure out that N2 is 3 over 2 mg, because remember cylinder 3 has N2, and cylinder 2 has N2 as well. So we have 2 N2. 2 N2 will be balanced by 3 mg here. So each N2 is 3 over 2 mg. So now let's look at cylinder 1. Now we only look at cylinder 1. So the forces that act on cylinder 3, F1 and N1, they also act on cylinder 1, but with opposite directions. For example, cylinder 1 will also have N1 along that direction and F1 along the opposite direction. So let's just look at the vertical direction. So N1's vertical component is N1 cosine 30 degree, F1 is F1 sine 30 degree. Due to the symmetry, cylinder 2 also offer same magnitude of N1 and F1 components. And then these forces will be same as mg. So this N1 and F1, they only equal to the half of the gravity of cylinder 1. So that's why we put half here. Then we simplify to get equation 4. From 1 to 4, then we get N1 is half mg, N2 is 3 over 2 mg, and F1 equal to F2 is mg over 4 plus 2 square root of 3, which with a quick calculation that will become 7.46. Remember, square root of 3 is about 1.73. Now from here, these two equations, so mu1 is equal or larger than F1 over N1, so that's 1 over 3.73, and mu2 equal or larger than 1 over 11.2. So only answer B can fit the condition here. So the final answer is answer B. Thank you for viewing. If you like my video, please comment, like, and subscribe.